So the other side of the mod motor, I was creating a degree indicator from 0 to 90 degrees so that we can keep track of where the modulation motor is versus all the other linkage components, and especially the air damper and the gas valve. So this was my first prototype. This is aluminum. What we have here is plate that I knew there would be a couple issues with. So one is these holes are raised up from the surface, so that creates a cantilever effect. My first mistake, which I was dumb, was I assumed that the hole for the shaft was in line with the hole with the mounting holes. So that is not the case. The mounting holes are offset, so I just drilled these out. That's why they look sloppy. But when you mount this here with a screw, and I knew this when I was designing it, there's this gap behind the plate, and when you mount it, it is tight. When people are grabbing at it and whatnot and grabbing the motor, and as they will do, one, it overhangs on the sides of the motor, and then two, they're going to be pushing on this top here. And since this is only an aluminum frame, these tiny screws, which are like 1024, it will cause these holes to start wearing out. And I knew that, and essentially still made this part, see how it is. Now you can make a support behind this, and obviously, you know, we could make a plate with this support or put a screw here and put a support piece, but that would dramatically increase the cost of this piece. Since this is just a sheet of aluminum, once you add a support piece, now you got to use a block to machine it. So how do we overcome that? This is just a prototype I made. But so I wanted to use the third hole to help create a more lined and rigid effect than cantilever, and then I made the holes bigger so that we would sit against the face of the motor instead of sitting on top of the mounting holes. So now we sit against the face of the motor, and we still have a gap on the top end, but we have complete contact all the way down behind here. So from here down is complete contact, and then with the third hole and everything flush, there's obviously flex in this since it's plastic, but it's now way more rigid and much more durable than just a single 2-hole plate that sits on top of these mounting holes that are like a 1/16 raised, and I just didn't want that for a durability standpoint. So this is the plate, and then I also shortened the plate here on the sides to help make it, if we were to bring this down all the way, you have all this overhang. So now you got to have all this to have a large degree scale, but then you shorten it down and brought it within the curvature of the modulation motor so that when people grab it, there's no overhang here, and it's very sleek. The other design issue is the pointer. So this is what I originally came up with. This is, I thought, all that I needed. Here's a standard pointer. Here's some set screws. You know, you cut a square in it, and then I laser engraved a line. This is the original setup. Once we tightened down the indicator, I found that the indicator was about 2.5 degrees off from where 0 was on this indicator plates. You can move the indicator plate to 0 the indicator, but once it goes to the other side, it won't stay on 90. So you have to adjust the position of the indicator on the shaft, and so it's essentially a 2.5 degree difference between the shaft, where it is, and the mounting holes. So the mounting holes supposedly are going to be parallel and square and everything to the mounting base and everything, and then this is going to be an exact 45 degrees to the mounting holes. Well, that is not the case. Now I need to make an adjustable indicator that is going to adjust for the air in the position of the shaft. And I tested it out on 6 different modulation motors, and all 6 of them had a different air. So it wasn't like just this one or a consistent air. So if you can't make something consistent, you got to make it adjustable. Came out with this indicator. This one's just plastic prototype. So we have a spinnable inside race versus the outside of the indicator. So the inside race has two screws, set screws, that are going to get attached to the mod motor shaft, and then the outside is going to get attached to the inside race. And so that allows me to put on the indicator, but then adjust the indicator position, which is not going to affect this. So using this, so this is going to be the plate. This is going to turn out to be aluminum, but we use this, and then we just adjust the indicator, and then we would tighten these set screws down, and now we have a zeroed indicator without canting the plate. There's 0, 0. So let's go and see how accurate this is. So we are going to go to 45 degrees. This motor travel is 90, so 45 is half of 90. It's right there. We are right on 45, and then we can take it all the way to 90. There, exactly on 90. Is this overkill? Maybe, but I never let somebody think that overkill or too much precision is not worth it for training. We want students to be able to know exactly where the mod motor position is. If we're going to move the position, now it's at 80 degrees. We want to see and track where our air damper and our gas valve are, because those will have exact degree marks as well. Without this indicator, or with a sloppy indicator that basically just shows general position and you can't go down to a single degree mark, that is not going to allow the student to know where this motor position is versus other positions of the linkage, the air damper, and the gas valve. Another thing this can show is showing students how much the modulation motor can move if there is loose linkage, and essentially how much hysteresis can happen. So this is low fire that we would say, so we're in the 0 position, and to measure and slowly move the motor and say, now we're at 5 degrees, and then now the gas valve starts moving, and now the air damper starts moving. So we have 5 degrees of travel in the modulation motor when we have loose set screws or loose linkage parts, and all that air and connections can show. So this motor can move back and forth 5 degrees, and the boiler thinks it's modulating, but no heat input will change. So then it keeps increasing the firing rate, and then finally it's going to overfire, and then we'll bring it back down. But this just adds another layer of visibility that I don't see anywhere on the market. And yes, it's probably overkill, but with the Boilearn Linkage Trainer, we are trying to remove all guesses and variability, and we're providing exact data so that students can quickly understand the troubles of linkage, and that once they understand the troubles of linkage, they will be able to adjust linkage, service linkage systems, but also show how much more parallel positioning systems are able to benefit customers' burners.